Hey, good evening, good afternoon, good morning, makers. How's everybody doing today? Welcome on into the Dragon's Den. My name's Digital Dragon, and I'm a 3D printing variety streamer here on Twitch. What does that mean? Well, it means we do everything from assembling 3D printers to building 3D printers, like most of the ones behind us here, to doing 3D prints like our cosplay helmets, to doing droid builds, what we will be here working on today. Welcome on in, everybody. Let's see. Pete Stavis, welcome in. Shadell, Ozzy. How's everybody doing? Stephen Poole, welcome on in. So, for those of you that were here on Saturday's stream and won something during the birthday stream, I believe everybody's been notified already. And I've got half the packages, I've got addresses, so they're packaged up, and I'm going to try and take them to the post office tomorrow. Need to do some running around tomorrow, and either Mrs. Dragon will drop them off at the post office and get them in the mail, or I will when I run out. I want to say once again a very, very heartfelt thank you to everybody that came out on Saturday and took part in the streamerversary/birthday stream. Thank you very much. Hope everybody's doing well today. Week started off well so far. Mine's been doing good, just chilling. Good. Good to hear it. For those of you that are stateside, we had I don't know, some little small sporting event on Sunday called the Super Bowl for American football, and that was that went good. I think it was a pretty good game overall, and I'd preferred a different outcome, but eh, it is what it is. I think everybody played well though. And after that, we started into the new season of all of our shows. So this is like premiere week for all of our TV shows here. Get all of our new seasons. No football talk. We're here for 3D printer stuff. Sounds good, Ozzy. Yep. And 3D printer stuff. So as you know, we're doing during the week right now. We're doing our droid build type of series. So we're working on the DO droid today. As soon as we're done with the DO droid, we'll kind of go right into the mini chopper build. So we'll work on that some. On Saturdays, we're building our Trident 350. Um, so the Trident 350 build here, we're starting to get into the electronics. We need to do the tool head and then the electronics. You hit sports 110% a day, so you're over it. Yeah, and you get a different type of football than the football that we talk about. We call that football soccer, but um, so I've got everything printed out for the tool head, fingers crossed, and we will do the filometrics tool head, which is the tool head that allows for cutting um, the filament versus trying to um, form tips or shape tips for your Enraged Rabbit carrot feeder. So the plan will be to finish this build on the Saturday streams, at least enough that we can push plastic and verify that it's functionally working, right? I'm not going to put panels on it and all that stuff. I want it functionally working. Then we will set that aside and we'll start building the Enraged Rabbit carrot feeder on. So the Enraged Rabbit carrot feeder will be the kit comes with a 6-cart Enraged Rabbit carrot feeder, which is the multi-material unit. And I've gone ahead and gotten the upgrade kit from Triangle Labs and Solid Labs. off AliExpress, and I'll be using one of those to upgrade the ERCFA 1.1 kit that came with the Trident to ERCFA V2, and going to keep with the same color scheme. So we'll get that build done, and we'll have multi-material or multicolor printing. And we have all of those parts printed. So all the parts for the Enraged Rabbit carrot feeder, so the MMU itself, and then all of the parts. Let me see if I can do this without dumping it over, because none of this is attached. For the Enraged Rabbit carrot tail, so this would be the buffer system, and the MMU will mount to the side, or the MMU, the Big Tree Tech MMB board will mount to the side of this. So we will be going through and doing all of this. I've got all of the parts printed except for the parts that are supposed to be clear. And I'm trying to do some research right now to figure out how people are printing those clear parts. Because if I go to try and do the clear PET G print, because once again, this is going to be outside the chamber, so it can be done in PET G for clear. Just doing the parts that I need to do, 8 like diffuser pieces, very small diffuser pieces, and then the 8 part pieces. It's 2 days, 10 hours going at the recommended settings for doing a clear PET G print. So I may be looking at possibly resin printing those, but I need to double check those as well. I don't know how best to do it. And quite honestly, I don't know if those pieces have to be clear to begin with. So it may just be a suggestion for clear, and I may just go ahead and just print them in a regular color. So we'll see. Hey, Hybrid Robotics, how's it going? Welcome on in. We're just kind of chit-chatting for the moment. Timur, welcome on in. So that's kind of some of the stuff that we've got going on. So Tuesdays and Thursday streams, we're going to finish working on the DO build. Once we're done with DO, I was going to say that we are going to do go right into the mini chopper build, but we may not. We may actually build one or both of the battle bots, the 150 gram combat robots, because I need to get Mrs. Dragon one that she can start practicing. So we'll see about that. It's either I may just do a separate stream, just pick a separate day to do a stream to do that build. But I think it should go fairly quickly. But we'll finish up the Trident build on Saturdays. I've got the invoiced. I've been invoiced for the black box build. I'm just waiting to get the shipping notification for black box. But I've got everything on order that's on my plate to order. So I've got everything to start doing all my tool heads. I think I have everything to start building the tool heads, and everything else should be shipping or should be going out via shipper this week. So yes, black box is coming soon. Micro crystal clear, it will make windows. I use it on your low scale model. So the piece in question is, I mean, it's about the size of this servo, right? So it's not a flat piece. It's literally a piece of the cart that it suggests printing out in clear. Um, I don't know if that's just to be able to see the filament path easier for troubleshooting, or if it's actually that way for like the LEDs. I don't know. I don't think it's there for the LEDs. I think it's just there to aid in troubleshooting. But I may ask that question in the forums. You're going to upgrade your Enraged Rabbit carrot feeder to V2. Yep. I have never built the Enraged Rabbit carrot feeder. So in my case, I will be building just straight to V2, um, following the instructions and stuff like that. And then, like I said, this will be a year for multi-material and multi-tool, right? So we're doing the IRCFA 2 for the Trident build. We've got the trad rack sitting up here that I'm going to reprint all the parts for the latest set of parts for trad rack. And that will be built in the color scheme of the K3 because it's going to literally be mounted on the side panel of the K3. Okay. And then that I think is like literally it's a 13 or 14 lane capability. I will never run that many colors, or at least I'm not planning on running many colors. I am getting a black box printer, Abaddus. As I was mentioning, it has been kitted out for me because I am getting a. So here's the deal I've got with Chris. He's given me the base printer to build on stream, and I am then going and checking out the tool heads of choice. So I am doing all the tool heads, and he is providing me the main printer, and I will build it on stream, and it'll be another person that has built a black box on stream. I doubt if I will get it done prior to Rocky Mountain Rep Rat Fest. I also will say it's not going to Rocky Mountain. If it goes to Rocky Mountain, it would probably be the only thing other than my table stuff that goes to Rocky Mountain. Because my wife is driving stuff out in a Kia Soul. And then I'm flying because I'm then driving back in a moving van to bring some stuff back from in-laws. So it's just a logistics thing. Now I will say that I have every intentions of it going to MRF, Midwest Rep Rat Festival in Goshen, Indiana, as well as to 3D Printtopia in Bel Air, Maryland. So, yes. We just look through here, and yes, everything has been ordered for the main printer kit, enclosure, the whole 9 yards. The only thing that's on back order right now is the actual build plate and the magnet. So it's just Chris is out of the 305 millimeter magnet and build plate. So hey Britt, welcome on in. So he'll ship me those whenever he gets them. If not, I think I may have a spare magnet. It's just not as good. And I do have a KB 3D plate that I can put on it if I need to during the stream, just show it. But I think he's going to get restocked before I make it that far. Because you know me, I try and do the beds as late as I can even if I have to jump around in the manual, just because it's, I mean, that it's a big plate. It's a lot of weight. And so trying to move a printer around, if you don't have that added just dead weight there, it makes life easier. Hey, Britt, welcome on in. You got a roof on the Kia Soul. I do have a roof on the Kia Soul. Um, that printer is a beast. That printer is not 2020 extrusion. That printer is, I believe, 4040 extrusion. It is not light. So it's not going to go on top of the car. It will go inside the cab of the pickup truck when I bring it to Midwest Rep Fest or 3D Print Token. But it's not making it to Remurf. Take the seats out and sit on the printer. You know, hey, I will tell you this. I took 3 printers, or no, I took 4 printers to Murph last year. A 300. So I took Fay Dragon. I took the Trident. No, I take it back. I took Fay Dragon. I took the 0G, a Rook, and a Prusa Mini. Because the Prusa Mini I was taking to Westry 1. At Remurf, I took 6 printers. I took the Trident, Kyber Dragon, the 0G, and 2 Rooks and a Rook 2020. So I took 6 printers, and this year going to Murph and Remurf, I am planning on taking Black Box. I am planning on taking the K3 with me to several shows this year because we don't get to see a lot of K3s, and we don't see a lot of K3s running at shows as much. So I do want to get the K3 out there, especially if I've got a trad rack that's working on it. So if I have trad rack and black box, that'll be awesome. And I know Chris is taking black box to Remurf and most likely to the other 2 as well. So I'm hoping that by Murph, we'll have me, Poity, possibly Steve Builds, and KB3D all having black boxes. So that would be really, really cool. Like I said, I'm just waiting for shipping notification for when that gets here, but everything should be here in a week or so once it ships. Because I think he's sending it USPS multiple boxes, so it's coming from Ohio to North Carolina. It shouldn't take a week. Hey, Shenanigans, welcome on in. I did jump into your stream briefly today. I just didn't say anything because I was sitting in meetings. So, but hello, and welcome on in. So the DO build. Sorry, Britt. I know we're here to talk DO. So on our DO build, we've been working on which scenes? On the previous stream, we've gotten our Lazy Susans, aka the wheels done. We got our main frame done, and we added our 5 pounds of ballast. And things can move, right? Things do move on the drive wheels, which are these black stripes right now. This is going to have to come apart later down the road after we get everything built. I will take things apart and paint the things that need to be painted. The white stuff will probably get a coat of paint just because I am seeing some. I mean, I had to print these very thin because you need to keep weight in mind as it comes up. Because everything on this tool head is going to be pivoting right here off of this lower servo. So all of this is cantilevered from this pivot point down here where my fingers are at. And so we want to be weight conscious up here where we can get a lot of this, some wibble and wobble. So right now I'm using M90S servos. There are options to use different servos that will be bigger. And in that case, if I wind up that the M90s are underpowered and they can't hold it well, then I may have to go and get some higher rated, heavier weight servos, which would be reprinting things like all the parts that the servos mount to or that mount to the servos. Um, like the main case here would be the same. It's just that cross member would be different. So I'd reprint what I need to reprint and keep everything else. But like this piece here will be taken back off. It will be um, smoothed down. I will paint it black and then probably do some rub and buff on it to give it a more of a metallic look or something and things of that nature. Um, so this is our base. And like I said, this is a bit of a heavy beast because we've got 5 pounds of lead balls down at the bottom of it, right? And this is where we were working on. We've got a servo down here in the main head, and that's going to allow the head to pivot, right, on this arm. It'll pivot on this arm. There's a servo here, and this servo is going to allow the whole head to twist. And then we're going to get ready to mount another servo, which will let the head kind of nod left or right. Okay. And that's kind of where we're at and where we left off. Now, I will tell you this black piece here is mounted onto the servo, and this still doesn't feel all that great. I'll put it that way. So when I do some mix some more 5-minute epoxy, I will add epoxy to this piece here to kind of add some additional strength because right now there's just a very small portion that's mounted to the servo arm. So I will go ahead and gob some on there just to help secure it to the servo arm a little bit better. Yeah, Dio is a pretty cute droid. And then the once again, our chopper build, well, I can pull chopper out now, or we can get the chopper. We'll probably get the chopper here towards the end of next week, anyhow. So we'll hold on and getting the chopper. So we were working in the head and neck assembly, yeah, the HeadBox and neck assembly, which is section 3 of the manual. And we had completed down to step 14. So that's where we're at, and that's where we're going to continue. So today we're going to install a screw on the top neck and start building out basically where the head itself is going to mount. So hybrid robotics, this is the DO droid. And I will put that in here. There we go. So this is the DO droid from Star Wars. He is I'll say he's the droid that was on the Millennium Falcon. Is the first time we see him when Rey and John Boyega's character, I can't remember. He's a Finn. There we go. Rey and Finn when they steal the Millennium Falcon to leave. that's where they come across DO. And so DO is basically what I refer to as the unicycle. Okay. Do not let it sing, it'll drive you crazy. Yeah. So I am going to try and do this. I will paint him accordingly, and I will I will paint him, and then over time I will go through and start trying to weather him up some. But I'm gonna have to. It'll be a work in progress on the painting because I've never really painted or painted for effect, right? So, but you see how the head assembly bounces around a lot. So some of that's going to be expected, but if it bounces around too much, then I'll have to update the servos to some heavier servos. But yes, this is the first droid that we're going to build. Hey, Rodney Mac, welcome on in. Welcome on in. Yeah, he is a little cutie. I'll give you that. So in our instructions, we're going to start back up on step 15, install the screw on the top neck. And we need a M3 by 25 countersunk screw. And I didn't buy any of these because I should have these. There's an M3 by 25, and we'll need a couple of M3 nuts. I'm not going to use the flat nuts. I'll use the some hex nuts here. Now, the guy that did the instructions, not Michael Badley, but the guy on the printed droid site suggests using lock nuts. And while I get the need to use lock nuts, I'm also worried about using lock nuts simply because of the amount of force. Like if I'm putting a lock nut right here on the end of a screw, no problem. If I'm trying to take a lock nut all the way back here, that it's very hard. Like you have to hold on to it with pliers and you have to crank some because you're basically pushing through that plastic this whole length of this thing. And trying to do that while it is going through a part is what worries me. Now, had they had me do it before I put this part on, completely different story at that point. But with this part already being mounted and being kind of tenuous, well, I guess actually, I mean, let's put it this way. That part is literally sitting on here with just a screw into the servos. So the more I think about it, we just take this out because where we're putting that screw is into this hole right here in this front half. So that screw is going to come in from the back side. And come out here. Now I could do a lock nut, which I've got several of those here from doing printer builds. But trying to do it while it's on there is what I'll say scares me. And I'll tell you this. Um, This did not epoxy very well, as in it did not epoxy on there at all. So that might be another reason why it was funky. So we're gonna have to figure that out. We may have to re-epoxy this. Hey Mayhem, how's it going? Oh yeah, I'm realizing that too. So I've got the parts for Dio printed. I've got the parts for mini chopper printed. I've got the parts for two two of the battle bots, and these are once again ant weight 150-gram horizontal spinners, and all of that's been printed out. I've got all the printed parts sitting here for Black Box, and I've got some lighting projects that I need to finish for the for the stream room here. And yeah, at some point I still need to get the Ender XY back up on the bench and try and work on that bed wobble still a little bit and clean up the wiring because it's horrendous. And then we're going to update the Voron V01 to a V02. So I have the lock nut on there, which is going to keep this from coming loose and getting wobbly. And then for now, I'm going to put the standard nut on here. Once again, I'm probably going to wind up taking this back off at some point. So if I need to go with a lock nut, I can go with the lock nut. Oh, so how about this? That's awesome. So um the epoxy did not stick to this plastic arm at all, but let's see if we can't get look-see at that center piece there. It looks really nice and shiny because it's a perfect imprint. Now, mind you, that's a printed overhang and it's nice and glassy smooth. So basically, it didn't adhere to the smooth plastic of this, and it filled in all the gaps here and made it smooth. So I probably just need to file the back side of this and get it reattached and then try and re-glue it. But file to rough it up some to give the epoxy something to hold on to a little bit better. But that would probably be why it felt like it did not, why it was so loose, is because it was literally just kind of sitting there. We'll get that there. We've got this piece screwed on there. We will go ahead and dab or do some more epoxy then. And then we'll just kind of slather that whole area up and see if we can't get it to stick this time around. Eating some chili before going to D&D tonight. Hey, rock on. Okay. And I'm going to get my stand, because this is kind of what we did on the last DO stream, was we used one of our boxes here to provide a stand to hold things in place. And we need to get our wires through here. And we will be getting into some of the wiring today. So that ought to be fun as we get into that later today. Just trying to figure out if I'm going to need to work on this. I think I might need to. If I can get any of the previous stuff off, or at least get it somewhat roughed up. Do that. That over like that. Hey, Printed Visions, how's it going? Hope you are doing well. We are doing pretty good here in the Dragon Den. Just trying to get ready to do a little bit more epoxy work here. So we've been working to get our DO build going and done. And uh-oh. No, it ended at 14 inches. Holy cow. I know that there was, I've got a few people that I work with that are up in like the Boston area, and they were saying that they were supposed to get like 12 to 14 inches today, and they had called a snow day like Monday ahead of the storm, and they were like, "Yay, snow day! We got 3 inches by mid morning." So I don't know if it really kicked in and dumped any more, or if it was just, kind of a lazy day off for a lot of people because of the anticipation of a storm that never really hit as full magnitude as they thought it was. Okay, so once again, I'm going to daub on that arm. And our servo wires run back through here. Down on there, and then we'll add a little bit more across the front edge here. Just get a little liberal with it. And once again, this is a 5-minute epoxy, so it takes about 5 minutes to set and then a full 24 hours to fully cure. So we've got our screw. We've tightened the first nut to secure it in place. The second one, second nut or lock nut, do not fully tighten it to the previous nut. This nut will be used in a later step. We're just putting it on for now. So this just means have 2 screws on this side, which is what I have. Now we're going to need to let this sit and dry because our next servo is going to get mounted right here. And if I mount that servo now before that dries, or at least becomes tacky, then we're going to have an issue. So we'll use the next MG90 servo, 2 mounting screws that came with the servo, feed the servo wires through the hole in the top neck. Okay, so it's going to come through this hole and out around the top, or out the side actually. Mount that in there with the 2 screws. Just kind of reading ahead to see what happens while this other epoxy sets some. This one, the servo horn, will then be mounted facing up towards the top. And in that case, I'll just figure out how it's going to set in there. Mount. It's going to mount this way. The servo horn will come from here and go up. It'll probably be easier to go ahead and just mount that servo arm while we're waiting for this epoxy to set up some. Kind of hoping that I could, if I had some more epoxy stuff to do, but I don't think we do for now. Hey, Zombie, how's it going? You've been lurking and forgot to turn on your sound? Way to go, Pezliz. Hey, Two Wolf Design, welcome on in. There's no snow outside on the south end of Boston. Yeah, my son lives in Goshen, and I haven't talked to him to see if he got like a lot of snow or not. You know, they tend to get some of that lake effect snow, so see. Once again, I'm just going to go ahead and take this and mount it for now. So, Zombie, on your tap changer, You kind of alluded, like, are you going to continue to build out the tap changer, or are you going to leave it at 2 tools and wait a bit? Oh, yeah, Goshen is Indiana. They get a lot of lake. They're sort of close to. I mean, it's where Midwest Rep Rap Festival is, but it's close to the Chicago area. So they tend to get a lot of the lake effect snow off of the Great Lakes. I should probably be working on this closer, you all. They can see a little bit better of what I'm doing. And I can't remember who it was. It might have been Turtle Crawler that had told me or suggested that I drop this from 60 frames down to 30 frames because it'd probably be a little bit better. Okay, you're slow in letting other people beta test. Yeah, I get that. So there is a hole in the side of the piece right here, and that's where we're going to fit our wire through when we go to mount this one. So we just kind of need to fish our wire through there. Would say the connector. A little bit. Probably going to wind up gluing this thing to this part by trying to get this in here now. Take this arm off because I'm actually hitting the printed part. Probably why they said to put it on afterwards. And did I just break it? Broke it, but broke it loose. So we're going to have to wait. We're going to have to wait and let that fully set up. Darn it. Can't get this in there just yet. It's going to be a tight fit. May have to do a little bit of filing to be able to get it in there all the way. Now let's let that sit and form up. Can we work on anything else while we're waiting? There will be a head plate, which will be this piece. And there is a M3 nut. Hole on the front of the head plate so that a screw can go through it. That would be this hole here. It's actually pretty close to being punched all the way through, so we might just be able to push through it. Oh, graphics much better. Got the Pro Designer to help. So the question is which Pro Designer? Quite a few. There aren't any more from cutting that open. We'll need a square nut. Once again, we punch the hole through the top there. Square nut. Going to go in from the front here. Push in. You may have to help it along. Make sure it gets fully seated so that it lines up with the hole nicely. Insert the screw mounting to the top neck through the hole in the head plate as shown in. Looks like it goes through the what? Okay, yeah. So the screw back here is going to go through this piece. And then the servo is going to get connected along the back here. Put up the servo horn with the cutout, the head plate, push the servo horn into the cutout. Not need to epoxy this servo as it will be secured in place with the second nut we installed earlier on this. Loosen the second nut or lock nut until it meets the head plate. You do not need to tighten this as the screw will just prevent the head plate from moving back. Okay, so we'll have the servo here with the servo arm, and we're going to use this nut to basically pull this tight against that servo horn to keep it in place. So pretty interesting. Let's see if we're now dry enough that we can try and massage this in here. know what the issue here is. It's the wires for the servo. I wish they made a version of servos where the wires came out like underneath versus the side. May have to like just file that area a little bit. So Britt, you've got Chuck Hullebuck tonight on your show, and I know that you've got your parts printed to do your the whatchamacallit, the Dremel mod for your thing. So when are you planning on doing your Dremel mod build for your stealth press? Much as I hate it, I'm gonna have to play this game. Or point it out. Dang it. Problem that I'm having is just clearance to get this other servo in there, and it's fouling with the front edge here. I think I'll be able to get it in, but just not get it in with the servo or with this piece mounted. There we go. Now I can get this mounted, hopefully drop it right back down on there. And of course, now I would have blocked the groove to mount that. Are you kidding me? 2 or 3 millimeters. That's all I need is 2 or 3 millimeters for this to not be a major pain in the arse. Now I know, Britt, you can tell me at any point in time that this is my fault for doing the higher complexity build for. Hey, Nicor, how's it going? Welcome on in. Happy to have you here, my friend. May have to open this up some more. There we go. That gets the big piece there, so we portal this guy in. That was painful. You need singers and dancers for your show, huh? Well, I've heard you sing. In fact, didn't you say something about, or somebody was saying that you were going to sing me happy birthday on your show? I just don't think I've been on there. Well, let me rephrase that. I saw you guys a little bit last night, but I was dead tired. I just couldn't keep going, so I kind of went to sleep early. Okay, so we got this mounted back down. This shoved through. I had to cut this opening a little bit more to allow this housing of the servo to be able to get down in there in that gap. And now we're going to mount our servo horn so it's straight up. You'll sing tomorrow or Friday? Okay. Okay, so that's mounted. And we got this prepped. Insert the screw mount on the top neck through the hole in one. That is the pointy side. So it's going to go through this hole here. And then the horn is going to set right here in this gap. So, and I believe all the wiring gets tucked underneath and off to the side. Just kind of have to wiggle it. So once again, we've got it on that screw, right? And we're gonna line it up with the horn right there. Just kind of push it back a little bit. Now we're gonna take this nut and move it forward. And that will be the friction fit that keeps this from coming back and allows the pressure to be there so that servo can turn the head. Good? There's kind of our head platform. Use any wobble. But don't deform it because this is a pretty thin print right here. Okay. Now we're going to do all the wiring for the connections in the head for the 3 servos. They want to cut all the wires to about the same length as seen in picture 1. Well, that's useful. Hold it all up and through here, so we'll pull everything up and through gently. And once again, these wires here are the ones that we pulled that go all the way down and out the bottom, right? So these come up through the lower box, up through the neck, and then off to the side here. And we're going to have a common positive and ground, and then 3 different colored wires that we're going to use for the signal wire. So all the positive and all the ground are going to be tied together between all of the servos. I just need to be able to write down like which color I'm using for which. So we're going to cut off the ends of the servos, keep these as we'll use them later. So good idea. The servos have 3 wires, orange, red, and brown. Separate the servo wires, strip the red and brown wires back about 1/4 of an inch. Find all 3 servo red wires and the 3 servo brown wires. Some servos have black as ground, but I have red, brown, and orange. So I just get the feeling like he's got more wire there than I do. I just feel worried that I'm not going to have enough or enough slack up in there, but we'll live with it. Strip the large red and black wires that will go to the body. Pick his reference. You can get a bigger picture here. Solder all the red, solder all the black, or the black and brown together. You're going, why did we run this up the one side? So be it. What I'm going to do is I'm going to try and line everything up with the red and black, give a little bit of room. You cut these, I'll say, a little bit longer than I would think I would need. I'd rather have them too long and be able to cut them shorter than not have them long enough. And then I'm doing crazy shenanigans. Well, Nomi, welcome on in. Thank you for joining. Thank you, thank you, thank you. So we are working on some wiring. They say to heat shrink everything together. I'll grab my heat shrink tubing. Heat shrink, there it is. We got some heat shrink. We need to do some soldering. So let's get the soldering iron over here. We got solder over here, so that's good. There's this part of me that sits here and thinks about this and it's like, do I want to solder it or would it be, I'd love to just do connectors, but I don't really have a good way of doing a 3-into-1 on a connector. Brown wires first. Yeah, I could use Wagos. We're trying to keep the weight down. But we could potentially do Wagos. Also have to figure out from a base type perspective, got the room to shove Wagos down. Your for sparks. Your way would really keep the weight down. Solder adds up. Um, See the bare wearers and sparks will add to. Yeah, yeah. Okay, so we got the stuff there to do the negatives, do the positives. Bring these 3 wires this side, just out of the way. Figure out where I'm at. So I'm going to move things kind of this way so I can prep for some soldering. There, we'll do this. Solder it right up there. That looks sketchy. Just know that it felt sketchy too. Okay. Group of wires connected. Next group of wires. Sorry, folks. No, I'm not talking. I'm just trying to solder up my wires and not burn myself too bad in the process. Also, not cross my wires in the process of it. So how you doing, Nomi? You feeling good? Still feeling all right today? Was there here? All reds to reds, all browns to browns, or browns to black. Of the hot air gun because this will work a little bit better and faster. Okay. Positive, positive, negative to negative. Now what? Um, heat shrink, heat shrink. Use electrical tape as well. So just super 3M Super 33 electrical tape. All right. Now strip all the orange wires and the other 3 wires that go to the body. Wire will go to a single servo. For signal, you can look at where the wire goes to know which servo you are working with. Wires going into the head box. Second and the third servo for the head plate. Yeah, so this is where we're just going to need to really document which wire we use for which. The same thing, we're going to strip the last of the orange wires and we'll connect them up one at a time to our other wires that we brought up here into the tool head, into the head. We just need to know which one we're connecting to which. Really? I wonder sometimes if I need to get my pins read or get a new pair of wire strips for the FEP wire. Doesn't seem to strip too easily. Huh? Now I do have these heat shrink butt connectors. And you use these small ones here, and that way you don't have to really solder. It's just hitting them with the heat gun. Um, I mean, that's an option that we can use here as well, rather than doing the soldering iron again. We can just use the heat gun for this. But once again, we've got to remember which color wire is going to which servo. You took your wife out to Taco Bell, so you're staying in tomorrow night. Very nice. Very nice. Um, yeah, I'm not sure where we're going to go tomorrow, or if we're going to brave going out tomorrow for that special day. It's up to Mrs. Dragon wherever she would like to go or whatever she would like to do. I will say that we ate out a lot over this weekend, so we shall see. Been a lot of leftovers going on around the Dragon Den here. Um, like I said, I've used those. I like them. They're not bad. But you just have to work with them. Um, I like them because you don't have to sit here and also do um your things here. But I also know in trying to do it, it feels like they get really soft and pliable for a little bit, and then they give you a little bit of time that you can kind of bend them or whatever, kind of get them into a shape. But once they cool off, it's pretty much where it's going to stay. It's not going to change shape without busting at that point. All right, so we got some heat shrink. We've got all of our wires are stripped. Let me go ahead and put my heat shrink on my servos, because otherwise they'll just go down this far. If I put it on the other wires, it's going to go all the way down into the head, and then I'm going to have head and neck. Once again, we're going to need to make some notes. We grab preferably a pad that doesn't have a diagram on it. So we've got blue, yellow, and green. Okay, and our different servos are head box, neck, and head plate. Okay. So let's do yellow for the one that goes into the head box. This one. Yeah, that's definitely cool. Like we're not huge on Valentine's Day either. I mean, to me, you shouldn't have to show love on a designated day. You should be showing love all the time, through various things and acts. Um, yeah. 5 for an hour. Are you taking off hybrid? Have a good night, my friend. Okay, so we're going the box, which is this one. Okay, fine. All right, so I went through and pre-tinned my wires, and we're going to do yellow going into the neck. Green is, or excuse me, yellow is the box. Green is going to be the neck plate or the neck itself. And then blue will be our top, our actual head plate. And you, and to get really fine strand copper wire to pen is kind of a pain in the butt. Okay, two down, one more to go. Okay, one last one. Once again, this is going to be the head plate servo. Here we go. So this is what we're looking like. So all of our browns go to black, reds went to red, and then each one of our signal wires came to a different color. And now I just need to heat shrink those, and that'll be power coming down and then the servo wires themselves. Again, where we're at, work on tucking these down. So once again, the blue is the head plate. The yellow is the box, the head box. Which makes the green the neck. We'll need to know that when we come down here to the bottom, because when we go to get everything going right here, we're going to have another connection, and it's going to be DuPont connectors, and we need to make sure that we get them all lined up correctly. Yep, definitely, Maker Viking. Definitely, definitely, definitely. Using heat shrink, slide the heat shrink and heat shrink. We did that. Yep, we use M3 square nut, the bar skin print, and the top bar print. Okay. Yep. Pretty. Um, Top bar print, I believe is this one. Pick one, you can see there's an indent in the wire channel that will hold the M3 square nut. That's down here at this end. I'm going to go ahead and take this slider piece off. So there's an indent down here in the base. Hold the M3 square nut. Grab one of those. Press it down in there. Go. It fell right down into place. Trying to get the light. Can't get the light to really shine spot to show that. There is a nut down in there. Get a different light source. There you go. You see the nut shining in there? About an inch in. Right here. Slide the wires into the skin bar with the slide bar over the head bar on the way up the head bar with printed notch. Yeah. Okay. Yes. So this piece, once again, printed notch goes towards the top, and all of our wires will go through this piece. So this just slides right over. We've put the wires down in that channel, slide over and come up to the top. And then slide the top bar print over the angle at the top of the head bar. We'll go over the bar skin and will be somewhat tight fit to hold it all in place. So that would be this print. Once again, it's black, but the center cross piece is going to be white. So I will have to do some work and paint this. I believe it comes down from the top just like that. That's somewhat loose. Huh, Gonna look just like that. So this is the top bar piece. Printed the bar skin in black and used a tiny bit of rub and buff silver on it to get a worn metal look. Did the same with the top bar print. That's what we're seeing here is um, he printed this out in black and then did rub and buff on it. Now I printed this out in black and then I sanded it. I could probably IPA this down, get rid of, clean it up some, and then potentially just rub and buff it. Same thing up here, rub and buff. Or in my case, I may try and sand things down to get a smoother finish and then paint it black and then rub and buff it, or use the graphite powder to give it kind of a Beskar or yeah, like a Beskar look. Now at the bottom here is where we're going to do some more work. Put that up there for now. Let's get some of this stuff out of the way. We're going to use the main bar holder print. Which is this print. Okay. Be the outside. This will be the inside piece. Feed the wires into the main bar A print and out the round hole back. Slide the main bar onto the head bar all the way up. Meet the bar skin as seen in picture 2. So down and then through that hole in the back, which may be a little bit of a fun time. Especially with these wires. Oop, I got them all. Very nice. So again, they get fed through there, and this is going to slide up and cover up the bottom of that base. Here, the main bar print with a 10mm long M3 screw. I'll show you kind of where I'm at here. Let me grab this screw real fast. So coming through the channel, through this gap, and then back down through the hole here. Then we're moving everything up until that hole lines up with the M3 nut and the hole at the base of the arm there. That's where we're going to put in our M3x10 screw that I just. And that's what'll hold the whole bar there. Do not push on the screw and let it screw in smoothly, so you don't push the square nut that's sitting inside that head bar out. And then you want to tighten it to secure it. Make sure that everything's nice and secure. Prep the um, main bar hole. Okay. Screw hole in the center of the main bar is covered for easier printing. Drill it out so an M3 screw fits in there smoothly. So well, tell me to drill a hole before I put wires where they're going to be in the way. They want me to drill that hole out right there in the center, which is well, right where the wires come in. Now let's go ahead and get the drill bit again, and we'll try and drill that out without drilling through our wires, which would have been easier to do without having the wires in there at all. So before we put wires in. Add time. Let's try doing it at random. Let me try and pull these out of the way as much as possible, and then I'm just going to pulse very slightly. Okay. Like I said, you're only going through one or two layers, so don't lean into it. Just let the drill do the drill thing. Now what's up next? Now you'll need the insert an M3 square nut into the nut trap, which is located near where the wires make the bend. So now you want me to put a nut in there where the wires bend through. And that's going to come down from the top down in there. So once again, something that might have been easier to do before we put wires in there. Just saying. You at least got it lined up. Coulda, woulda, shoulda drilled the hole and then put in the nut and then played with wires. You'll need an 8 millimeter long screw in the main bar cap. So this is the main bar cap. We're going to need an 8 millimeter screw. Once again, it's a countersunk screw. So we'll grab an M3x8. fit the screw into the hole to make sure that it goes all the way in. And if it doesn't, then use a knife or something to open it up slightly. Don't go crazy. We want it to go in, but we don't want it to be crazy. Okay? A little bit of elephant's foot on this part. This is going to need to be painted, I believe, anyhow. So what we're going to do is we're going to screw this screw in, and then we're going to epoxy it on here so that when we screw it back in, we're going to screw it using the printed piece here, and everything will line up right. And once again, it does pop on there, so that's good. Use some sandpaper to rough up the head of the screw so epoxy will stick to it better, shown in picture 1. So in this case, you just put your sandpaper down on the bench and then take the head of the screw and rough it up. Probably not use the finer grit. You just want some scratches on there so that it'll have something else to hold on to. Mix up a small amount of 2-part epoxy to drop onto the center of the, screw it into the mini bar clamp, just barely tight, do not over tighten the screw. So we're going to screw this into this mini bar clamp here. Which nut is not fully seated, so let me fix that. Oh, now this will go in. Again, just until it snugs, right? It's not going to be all the way in, right? That is not all the way in snug. Fine, that's where we want it. Now, you need to try and lay this here and hopefully it'll stay. Because we're going to need to mix up some epoxy and put a dab of epoxy right on that head of the screw. See if we can't go right there in that corner. Really, really don't need much, like just the tiniest little bit. But don't worry, I mean, we're not using that much epoxy at all in this project, so we're going to have plenty of epoxy to last. I mean, we're still really good on epoxy, and I've got a whole nother tube if I need it. So we're not worried about the epoxy. We're just trying not to use a whole ton of it if we don't need to. So we're just going to take this and mix it up like we did before. Sure, it's mixed nice and good. Got it. Mixed. Like I said, we're just going to put a dollop on there. We're going to take our piece, and it looks like he has it going horizontal to that piece. We're just going to take this and set it right on top, just like that, and clamp it. Now I've got a pair of clamps here. These might be a bit too much, but hopefully not. Make sure the clamping force is where you want it. You're not crimping your wires. And just let that set up for a while. And hold it for a little bit. Allow the epoxy to fully cure, preferably 24 hours so that you know the bond's going to hold. Then you'll try and remove the cap by unscrewing it. If it doesn't fully cure, when you go to unscrew the cap, it can and will just snap off, and then you get to go through and do the whole thing again. Worried that I'm cramping or clamping to the wires. I really don't want to. And I swear that almost all of this piece right here could have been done before doing any of the, pulling any of the wires through here. This is kind of like self-inflicted pain, right? That puts it off at an angle. We're gonna let that sit there for a good long while. Um, and then you would use that main bar clamp to actually unscrew it. And then it says here that he used a little bit of epoxy afterwards to make sure that the screw is in the right orientation so that when you screw it back on, it'll go back to that right orientation. It won't be all wonky or crooked. That's all we're trying to do there. And then the last part here is it's going to cut the wires and install a 6-pin DuPont connector, which we're not going to do now because I need to leave this to dry. I can't do the wiring down here at this end until this is dry. So we'll have to do this part of the wiring on Thursday. So once again, we've got to do the DuPont connector at the end of this on Thursday. So let me make a note of that. So I got a note of that. So we can do that on Thursday. Jump back here. Whoops. Whoops. I think I just did something wrong. We go back over here to the Suzuki. There we go. So we've done the Lazy Susan, which is our drive wheels. We've done the main frame assembly, and we've done the head box and neck assembly. The next up would be the top frame and the electronics wiring. So this will be crimping the main bar wiring. So here we'll use the wire that we trimmed off the head bar to continue the wiring. So we'll need these pieces that we cut off, unfortunately. So we won't be able to do that piece just yet. Okay, so the second piece here is once we make our wires, in our main assembly here, we're going to run those wires through that opening in the main shaft until it comes out the front side of our part. Motor driver, we'll start working on this piece. I'm going to take this and just move it to the side for the time being so that I don't knock it. And we let um, that epoxy fully set and cure before we do anything else on that piece there. I think everything else we're going to be working on here. So not sure if we'll be using any more screws and stuff just yet. I'm sure we will, but that stuff out of the way. This stuff here we'll probably use a little bit of that. Okay, so the Citron motor control. There it is. This is the Cyton motor controller, the MDD 10A. Come with 4 white clips or standoffs that have an M3 threading on them. So there's our board. We're going to insert these from the bottom of the board. So these little arrow clips go through the board, just like that. These are going to be the standoffs that we'll use to screw the board down. Got all 4 corners done. Then we're going to mount it in here. And so our screw terminals line up with this hole at the top and this gap in the front. So your wires can go in and you have the ability to screw the terminals. And then this hole in the back is where your connector goes. So this is going to slide in there just like that. Then we'll line these up and screw them down. Motor driver and the motor frame attached to the main frame with 4 M3x10 screws. So how's everybody doing? And what do you think of this build so far? Something a little bit different than we're used to doing, huh? Thanks, Liz. Hopefully it's, we all learn from this. So we've got our main frame piece. And there's that cutout gap that we're seeing. This is this cutout U-shaped gap that we're seeing right here. That looks like that's where the motor wires is coming out to this side. So it's going to sit down in this cleft like that. And we're going to flip everything over and make sure that we're lined up. And we're going to screw this in with the M3x10 screws. Going through the base plate, through this plastic piece into these. And we're going into a plastic standoff. Just be careful that we don't crank down on this too tight and strip the plastic. Okay. Once again, this is that left front edge for the motor wires. And then there's the rear edge of it. And it's a little bit hard because these these tend to rotate, but I think we're good. We got all 4 of them in. Now let's see. Attach top frame to the main frame. We're gonna have to take our Lazy Susans off and get to our main frame again. So 3 screws on each side. All right, be safe, Pete. Thanks for hanging out. Hey, Monlight, how's it going? Welcome in. There's one of the Lazy Susans there. Turn this around. We'll take the other 3 screws out. Take this side off. There we go. Take the main wheel out. We're back to our basic side panel, or the basic main piece here. And how are we looking here? A few things to do before attaching the top frame. First, plug in the drive motor wires. If your motors have pluggable wires, my motors are shorter than the ones Michael used, so I also had to bend back the plugs slightly, as seen in picture 1. So he was using these encoder wires. We're not. We've got our wires not plugged in, but soldered directly on. So these are our 2 wires. Place the top frame on the frame, bringing the drive motor wires through the hole in the top frame, and the main bar wires, center servo wires, will be in the notch on the side with the motor driver screw terminal. And that's the part. So we will need to bring these wires through as well at some point. So I'm going to mount this way, and it comes out towards this. So in this view here, the cutout opening goes towards the front. I'm sorry, the back. This is the front, this is the back, supposedly. But where your cutout is, where your servo wires go, and that's where your wires are going to feed through and come out here. So the wires, when we go to fish them through, are going to come through here into the hole and then out towards the front. So I'll probably have to take this back off later on. It's not that big of a deal. There are holes here and here. That's where your motor wires are going to come up through. We can go ahead and get our motor wires started there. Make sure that nothing's getting caught as we put things in place here. everything down. Like I said, we'll have to dig in there and move some things around once we get our wiring for our head done. Bringing the drive motor wires through the holes in the top frame and the main bar and stuff through this hole down here. Using 6 M3 by 10 screws attached the top of the frame to the main frame. 4 screws near the corners of the motor drive frame. 1 at each far end of the frame for a total of 6. And like I said, I'm going to go ahead and just put these in here. We're going to put it together and take it apart numerous times, so that's no big deal. There are screws 1, 2, 3, 4, and then 1 on each end to make 5 and 6. So 1, 2, 3, 4, 5, and 6. We got those done. Now we need to do a switch and get some uh, pieces ready. This would have the Dean's connector. And I just want to see something real fast. We'll need 1 male, 1 female T-plug Dean's connectors that match the batteries used, blah, blah, blah. Plug it in. So we're going to be a little bit different here. And this will be the nice thing because I'm not going to say I cheated, but I went the easier route. And we decided to get some circuit boards, right? So instead of, doing all of this soldering and stuff like that, what we've got is screw down terminals for our switch. So we got a screw down terminal for our switch, the screw down that goes to the motor driver, and the screw down that goes to the controller. And then we've got the XD60 plugs for our batteries. Now, once again, if your batteries have Dean's T connectors, you could have soldered in the T connectors instead of these. If you ever swap over and get T connectors, you can add T connectors and you'll be ready to go. So what we can do is we're going to take this piece. I might have to fiddle a little bit to get the wire around there. Get it around the wire. And the board. Tight fit. Oh, there you go. Pop and down, pop and down, pop and lock. There we go. That board is a really, really solid friction fit in there. I'm not even sure if I'm even going to try and do anything to bolt these down, but our switch is going to get made and go right here, and we'll come right off that switch and right into these screw terminals. And then once again, our batteries will come out and just plug in right on each side. This provides power. The switch is, of course, going to turn it on and off. We'll have power that gets brought up to the motor driver board, and then power that comes up to the controller board that will feed everything else. This dramatically simplifies the need to do all of this wiring here. We're just going to need to make some stub wires that go from our chosen switch to this screw down terminal. And I believe I'll have to check, and I might even have to dig, but I should have a switch. I just have to dig in here and get it, because I didn't think we were going to get this far this quickly, so I haven't been looking for the switch. So bear with me for a second here, folks, while I look for that. And of course, these are standard 4-pole instead of 2-pole switches. So darn it. It'll work because it just presses, just press fits in. Um, yeah, and quite honestly, I could care less about it lighting up. This is all it is you'll apply power in and then power come out, and it gives you a lit up switch, which I could care less about. Well, mm, oh wait, I think I have other switches inbound because I did order some. So I'll wait for just a standard, uh, I'll say a standard regular switch to come in and arrive. So I don't waste those ones. So we'll order another switch, and I could probably have it here by Thursday. That's no big deal. Not like we really need the switch in place at this point, anyhow. A used replicator tube. Will define a ton of extras, month, right? So as you can see, the wiring in here starts getting kind of crazy. Um, what this is why I got the circuit boards, is because I think it winds up working out a lot easier. Um, These are the final two power wires attached to the center screw terminals on the motor driver. So this is where we would take jumpers from the motor driver here into the center two terminals of this motor driver. So that's all we need is a jumper right there. That's a short 18 gauge. I might even have plenty of spare wire here. Take one of these and do that jump. Probably so. Hold up and put a zip tie on the remaining motor wires to keep them clean and out of the way. Okay, yeah, so here they're just using the main wires. Okay, so positive on the inside, negative on the outside. And really, we're talking about going like here, and this one coming around to there. So there, okay, there. And these are standard screw down terminals, so I will put ferrules on these. Grab the ferrule kit. And like I said, this will give us another piece of wire that we can go and make our jumper there to there. So yeah, that's why I said it all depends on what the extras are and what can be done with the extras. Okay, so we got the ferrules. Once again, these are 18 gauge wires, so we're using our red color coded ferrules because those are our 18 gauge. Give these a twist to make sure that our wires stay together. Big crimp. Same thing for the other one. Do on the other side here. And we may have to cut these, well, don't have to, but if I get a lot of exposed metal on the ferrules after I insert the ferrule into the screw down block, I will trim like the last, whatchamacallit, the last little piece off of the ferrule just to make sure that it's nice and clean and no chance of arcing between ferrules that are right beside each other. this longer piece here and get it prepped as well. We'll have, so for those of you that have arrived later, um, I do have an order placed for the black box stuff. I am getting a black box out of the first shipment batch. It is going to be a full kit except for the tool heads. I've bought all the parts for my tool heads of choice. I am going to do a 4 tool head machine to start with and leave that 5th tool head for an option down the road. This is what I was talking about, is these little segments here. If it's too long and it leaves some of the metal exposed down here in the screw terminal, I will trim off that first segment so that these bury down right to the insulation, so there's no chance of arcing when these are installed side by side. Or at least it's significantly reduced. Positive on the right, negative on the left. I'm hoping ferrules would work here. Open all the way, or I have to smash the barrel some. Anybody else ever have problems getting ferrules to go in sometimes? I don't know if it's just I'm not getting them like squared up to the piece, or the, the, wow, or that could be all the way in right there. I have a feeling that's all the way in, and if so, and I don't know if you can see in there. See how much of that barrel is left exposed? So I'm going to wind up cutting probably 2 segments off the end of that ferrule, and all of them, so that they will go in and be fully seated. And try and remove any chance of an arc. Using a Model T to make a Corvette. And all I'm doing is doing a little bit more compression on it. That's also helping it get seated in there well. Okay, hang on these now. Make sure when if you do this where you do some additional compression on it, you make sure you're really aligned with the flats. You don't round these off because then you loosen up the crimps on them. And these wires, the positive were on the inside, right? Positive on the inside, negative on the outside. Doing one piece off the end. And you'll notice when I am cutting these, I'm facing it away from me and I'm putting my finger underneath it so that it doesn't go flying all over the place. You want to be careful of these little metal shards. One, you don't want to get one in the eye, and then two, you don't want them flying around loosely all around your shop because well, you got a lot of expensive electrical things, and you don't want to uh, short anything out, set anything on fire. That's one motor, and I'll be able to, just route this around however I need to once I get things in here. Keep things nice and tidy. This motor is going to come over to this side. Then we're going to trim one piece off the end. Both of them. Then we'll go ahead and add a little more Ugga Dugga to the crimp. Making sure we're lined up on the flats. And then once again, the red power cable goes to the inside. And then for these. Line these up here. Then this one comes over to our motor driver. Negative is towards the driver board, positives on the outside. Get these stripped and going. And like I said, I have a feeling that I'm going to be putting this in and out fairly often, so not that worried about um, this stuff. I know I'm going to have to um, undo and unscrew some of these once we go to work on the other wires coming from the head unit on Thursday. But gives us good practice at putting it together and taking it apart. Or at least that's what I'm going to tell myself. Okay. Got these done. We're going to do our little added compression. Seems to really help be able to get them in easier fully. And once again, negative towards me, positive away from me. Into that. That's what I want to do is run this underneath because eventually I won't need to be undoing this center wire for most of the time because it's where it stays on this board, so it doesn't really need to come out all the time. But these motor wires would need to come out if I'm going to open the edge up. So just be cognizant of that. So you know how best to route your wires to keep from having to undo a bunch of things that aren't necessary just to be able to get a board out. What is going on? So these open up in very small slits. That's what I'm trying to deal with right now is getting everything lined up just perfect. Try and get in that slit. Well, I pretty much had to trim these flat, and then they have to be lined up just right to be able to shove them in there and screw them down. But done. Hey Ramon, how's it going? Welcome on in, welcome on in, welcome on in. We'll make that a little bit shorter, but we'll be good there. So we've got power from the circuit board to the motor, and then both motors are connected in. That will be the primary motor wiring right there. And this is the servo that will be for the main head servo here. And once again, the switch is going to get mounted right here and just go right into this screw terminal. The batteries are going to slot in the holes and plug right into the XT60s. So we'll have power, we'll have switching, and then the controller comes from here and goes up. Now attach a Dean's connector to UBEC. Here we'll have a 5-volt, 5-amp UBEC to control voltage. To the rest of the electronics, since we wired the batteries in series, they're over 14 volts, and we need everything else to run at 5 volts. Sounds good, right? We don't want to overpower our board, and it calls for using a UBEC to downcycle that power from 14 volts down to the 5 volts. Now, my understanding is we're going to come off of this board. We're going to come into this board right here, 10 amp fuse, MOSFET, 10 amp fuse, buck converter. It says right next to it, just step down to 5 volts. So we're going to want to put a meter on this and make sure it's 5 volts coming out of here. But that's the other nice thing about the board is we don't have to worry about a separate UBEC. This is going to mount up here somewhere, and it's going to come right from here to here, and then everything else is pulling power directly from this 5-volt buck converter. So makes our wiring a lot easier. Motors, this will be for our servos and everything. So yeah, it's going to make our wiring a lot easier. Here's his power board. Once again, it's 2-piece power board. So this top board, the board that I'm using, you make all your attachments And then your receiver gets attached in here as well. If you're using the standard size receiver, if you go with the small receiver, the what is this FS whatever 2A server or receiver, then you go basically via iBus. You don't need a couple of things. So here's that tiny receiver. You connect into the iBus, and so you don't even need like this part of the board anymore. It's even smaller. There you go. The FSRX2A Pro or Pro V1. What I was looking for here was I thought picture the installed board. This is what I wanted to look at is how they kind of ran their boards and what their wiring looked like. As you can see, the batteries come up on either side. You'll have the switch. Then we have our motor wires coming in. Hoping they had an actual wiring, but I guess not. Let's see on the shop. I want to say for whatever reason, I have seen a wiring diagram. That's what I'm trying to look easier. Oh my. Dang it. Well, I guess I can't be that uh, easy, can it? All right. I guess we'll have to work our way through these, but we don't need the U-back. At least I'm pretty darn sure we don't. Connectors to the servo wires. Now work on the wires coming from the main bar that we bent to the side earlier. Still can't work on those because we need to wait for our main bar to fully set up, which will be sometime tomorrow where I can take that apart. Um, it looks like we'll crimp the three servo signal wires together. And then what we're going to wind up doing is on our servo piece here, it goes signal positive, negative. So we're going to basically line it up 1, 2, 3, and run our servos right next for the signal pins on 3 of these pins. And then we'll just bring the power and ground in as a separate pin out. Da, da, da. And the power wires coming from the head will get added to the power wires here and go up into the board as the final connector, final 3-pin connector. Call the header on the MPU. This is the MPU unit. It's already built on with the header, so we don't have to worry about that. We've got the header already in place. Attach this to the Arduino base. We're already there, so we don't need to do that, but we do need to just reading through to see where we're at. I think we're starting to get into some complicated things. It's kind of an 8:30 time frame, getting close to 9. I need to look through here again and double check the wiring schematic and make sure that we don't wire anything up wrong. Okay. Um, so basically what I'm saying is, I think we're going to call the stream for the night. We started making some good progress. I want to go ahead and get the head wiring done so that we can bring that in here as well. And we're going to continue to work all the wiring on the main board here. I got to grab my at Mega at coming in here. Oh, knew I had one of these here. I also got a couple of ramps set up, so I know I've got an at Mega right. But we'll be mounting this as well, and this will slot directly on top of the at Mega, just like normal. So I think that's kind of where we're going to end it today. Oh, my camera froze. Why did my camera freeze? That's not good. Camera freeze? Yeah, so my camera froze. So I don't know why. So we will kind of do like this and say, hi, everybody. I'm going to go ahead and let's check out real fast and see if Creatix Brit is on. I think she was coming on early tonight, interviewing Chuck Hullabuck. Anybody verify for me? On at Nope, she's not up yet. Um, so I will say Creatix Brit is interviewing Chuck Hullabuck tonight on her channel, and I believe that's at 9. So be cognizant of that. Keep an eye out for that. But for right now, let's see who's on that we can run over to. Gang's doing a Lego build. Heresy looks like he's working on a ball machine. Astro Canuck for Science Stream. Babe Ross for art. Um, Few other people I think are just really playing games. What do you guys think? Who do you want to go see tonight? Maybe let's run over to Babe Ross, and then once again keep an eye out for Creatix Brit. Keep looking over here because that camera froze. Sorry about that, folks. Yeah, I'm going to go ahead and get a raid started over to Let's go to Babe Ross. We haven't been over to Babe Ross in a while. And yes. So thanks everybody for being here this evening. We're making some good progress on the Droid. Once again, we'll come back on Thursday and continue the Droid build. I will have the other part ready to go. Well, not ready to go, but ready to continue the build so we can do some more wiring on the next stream. Thanks everybody. Have a good evening, and we'll see you on Thursday. Bye now.